There is a concept in longevity research called biological age. It is not the number on your birthday cake, it is the number your cells are living at. And the gap between those two numbers, between your chronological age and your biological age, is one of the most meaningful predictors of how the next decade of your life actually goes. Here is what the research shows. That gap is not fixed. It is not determined by your genetics alone. It is shaped continuously by what you do on an ordinary Tuesday, not by dramatic interventions, not by expensive treatments, by small, consistent behaviors that most people overlook precisely because they are small. A 2023 study from the Duke University Center for the Study of Aging tracked adults from age 75 onward and identified a cluster of 5 behaviors that were present in the highest functioning quartile. The people whose biological markers, cognitive scores, and physical performance all told the same story. They were aging measurably slower than their peers. None of the 5 behaviors was extraordinary. Every one of them was something you could start tomorrow. I am going to walk you through all 5, explain the biology behind each one, not the surface level version, the actual mechanism, and give you a specific practical way to apply each one. Stay through habit number 3, because the research behind it is the most counterintuitive of the 5, and it is the one I find almost no one over 75 is doing consistently. This channel is built around one premise, that the health information available to adults over 65 is too often generic, too often designed for younger bodies, and too rarely grounded in research that was actually conducted in this age group. Everything I cover here comes from peer-reviewed research, and I try to be honest about what the studies actually found versus what headlines claim they found. Those two things are often not the same. Before we get into the 5 habits, how old are you? And what is the one small thing you do consistently that you feel genuinely contributes to how well you are aging? Drop it in the comments. I read them and I learned from them. I want to take 90 seconds to explain what biological aging actually means at the cellular level, because it changes how you understand everything that follows. Your cells contain structures called telomeres, protective caps at the ends of each chromosome, similar to the plastic tip at the end of a shoelace. Every time a cell divides, the telomeres shorten slightly. When they shorten to a critical length, the cell either stops dividing or triggers its own death. The rate at which this shortening happens, and the rate at which other cellular damage accumulates, is what determines your biological age. A second mechanism, chronic low-grade inflammation. Researchers call it inflammaging, a persistent low-level inflammatory state that accelerates cellular damage across virtually every system in the body: cardiovascular tissue, neural tissue, muscle, bone. Inflammaging is the common thread running through most age-related decline, and it is powerfully modifiable by behavior. A third mechanism, mitochondrial efficiency. Your mitochondria are the energy-producing structures inside each cell. As they age and become less efficient, they produce more oxidative byproducts, reactive oxygen species, that damage cellular structures, including the DNA itself. The rate of this mitochondrial decline is highly responsive to specific behaviors. The 5 habits I am about to describe each target one or more of these 3 mechanisms. They are not random wellness tips. They are targeted interventions at the biology of aging itself. Habit 5. They eat within a consistent daily window, not a restrictive diet, not caloric deprivation, a window. The concept is called time-restricted eating, consuming all food within a defined period, typically 8 to 10 hours, and allowing the remaining 14 to 16 hours as a fasting window. The research behind this in older adults has grown substantially in the last 5 years, and what it reveals is that the timing of eating matters as much as, and in some cases more than, the composition. Here's the mechanism. Your cells have an internal maintenance program called autophagy. The word comes from the Greek for self-eating, which is not as alarming as it sounds. Autophagy is the process by which cells identify and break down damaged or dysfunctional components, misfolded proteins, damaged mitochondria, debris that has accumulated inside the cell, and either recycle the usable parts or eliminate the waste. It is a cellular quality control system. Autophagy is suppressed when insulin levels are elevated. Insulin rises in response to eating and remains elevated for several hours afterward. When you eat continuously from morning until late evening, as most people do, autophagy barely has a window to operate. The maintenance program runs intermittently at best. When you consolidate eating into a defined window and allow a longer overnight fast, insulin falls, and autophagy has the sustained runway it needs to do its work. Damaged cellular components get cleared. The mitochondria that are no longer functioning efficiently get recycled and replaced. A 2022 clinical trial, published in Cell Metabolism, followed adults aged 65 to 80 assigned to a 10-hour eating window for 12 weeks. The results showed significant improvements in metabolic markers, fasting glucose, triglycerides, blood pressure, as well as improvements in self-reported sleep quality and daytime energy. These are the same markers that diverge between fast and slow biological agers. The practical version of this is far less dramatic than it sounds. If you finish dinner by 7 p.m. and have your first meal at 9 a.m., that is a 14-hour fasting window. You are not skipping meals, you are not going hungry, you are simply compressing the eating period and letting the overnight maintenance window run properly. Think about what this looks like in a real life. A retired teacher, mid-70s, who noticed she had been grazing continuously from a 6 a.m. coffee with cream through a 10 p.m. evening snack for decades. A 16-hour window with no real break. When she shifted to finishing dinner at 6:30 and not eating again until 8:30 the next morning, no other changes. She reported better morning energy within 2 weeks. That is the autophagy window working. Important note for this age group. If you are managing diabetes, take insulin or blood sugar medications, or have a history of disordered eating, please discuss any changes to your eating schedule with your doctor before implementing them. The benefits here are real, but the right structure for you depends on your specific medical situation. Habit 4. They move within the first hour of waking. Not a workout, not a gym session, movement, intentional, deliberate morning movement. This habit operates through 3 separate mechanisms that compound on each other, and I want to walk through all 3 because they each address something distinct. The first mechanism is cortisol timing. Cortisol, commonly called the stress hormone, which is an incomplete description, follows a predictable daily pattern. It peaks in the first 30 to 45 minutes after waking in a surge called the cortisol awakening response. This surge is intentional and healthy. It is what mobilizes energy for the day, supports immune function, and sharpens cognitive focus. In healthy aging adults, the cortisol awakening response is robust. In adults who are aging less well, higher inflammatory markers, worse cognitive performance, it is often blunted. Morning movement amplifies the cortisol awakening response. It gives the cortisol surge something to do, a physiological demand that matches the biological preparation. Research from the Journal of Clinical Endocrinology and Metabolism found that even moderate morning exercise enhanced the cortisol awakening response and produced measurably better sustained attention and executive function throughout the day compared to sedentary mornings. The second mechanism is blood glucose regulation. Overnight fasting leaves blood glucose at its lowest point of the day. Morning movement, even a 15-minute walk, activates GLUT4 transporters in muscle cells, which are specialized channels that pull glucose out of the bloodstream and into the muscle without requiring insulin. This is particularly important for adults over 75, where insulin sensitivity has often declined, and morning blood glucose management is more challenging. A 2020 study in Diabetologia found that a 10-minute walk taken within 30 minutes of waking produced a significantly better blood glucose response over the subsequent 4 hours compared to no morning movement, even when the total daily step count was equivalent. The timing, not just the amount, drove the effect. The third mechanism is circadian anchoring. As I explained in a previous video, the circadian rhythm becomes less robust with age. The peaks of wakefulness and the valleys of sleepiness flatten. Morning movement, particularly outdoor morning movement where light exposure accompanies the physical activity, is one of the most powerful signals available for anchoring the circadian rhythm. It tells every clock in every cell, the day has started, synchronized to this. The practical application is genuinely accessible. A 15-minute walk immediately after your first morning drink. A few minutes of gentle stretching and bodyweight movement before sitting down. The form matters less than the timing, within the first 60 minutes, before the day's first demands pull your attention elsewhere. If mobility limitations make walking difficult, seated range of motion exercises, resistance band work from a chair, or gentle standing movements against a stable surface all qualify. The goal is to send the body a morning signal, not to complete a fitness protocol. Habit 3, the counterintuitive one I mentioned at the start. The adults in the highest functioning group after 75 practice some form of deliberate cold exposure, not ice baths, not cryotherapy chambers, something far more accessible than that. But the research behind this practice is more compelling than almost anything else on this list, and it targets the mitochondrial aging mechanism directly. Let me explain the biology first because it is not obvious. Your mitochondria, the energy-producing structures in your cells, have a quality that is rarely discussed. They respond to controlled stress. When your cells are exposed to moderate, manageable stress, the kind that does not damage them but challenges them, they activate a set of cellular defense and repair pathways. The biological term for this is hormesis, the principle that a low dose of a stressor produces a beneficial adaptive response. Cold is one of the most well-studied hormetic stressors. When the body is exposed to cold, several things happen in sequence. Norepinephrine is released, a neurotransmitter and hormone that has direct anti-inflammatory effects, particularly in the brain. Brown adipose tissue, which is metabolically active fat that generates heat by burning energy, is activated, and mitochondria in muscle and fat tissue upregulate their activity, producing more of a protein called PGC1 alpha. PGC1 alpha is the master regulator of mitochondrial biogenesis, the creation of new mitochondria. It is the signal that tells cells to build more and better energy-producing machinery. In aging muscle and fat tissue, PGC1 alpha activity declines. Cold exposure is one of the few reliably demonstrated stimuli for restoring it. A 2022 study published in the International Journal of Molecular Sciences found that regular cold water immersion in adults over 60 of as little as 2 minutes of cold water exposure 3 times per week produced significant increases in norepinephrine, reductions in inflammatory markers including interleukin-6 and TNF-alpha, and improvements in mitochondrial efficiency markers compared to a matched control group. A separate line of research from a 2021 paper in Cell Reports Medicine found that cold exposure increased the expression of longevity-associated genes in human subjects, specifically genes related to DNA repair, oxidative stress resistance, and cellular stress response. The effect was present after just 4 weeks of regular cold exposure. Now here is the practical application, because I am not suggesting you submerge yourself in ice water. The minimum effective dose, based on the research, appears to be 11 minutes per week of cold water exposure, distributed across 3 or 4 sessions, not all at once. That is 3 minutes 3 or 4 times per week. The most accessible form, the last 2 to 3 minutes of your daily shower, turn to cold, not ice cold if that is not accessible, meaningfully cold. Cold enough that you are breathing deliberately, cold enough that your body is responding. The first week is genuinely uncomfortable. The second week is less uncomfortable. By the third and fourth week, most people report that something shifts. Not that it becomes pleasant, but that the discomfort becomes manageable, and there is a noticeable change in alertness and energy in the hour afterward. That alertness is the norepinephrine response, which has a half-life of several hours. 2 important cautions for this age group. First, if you have cardiovascular disease, a history of stroke, Raynaud's syndrome, or uncontrolled high blood pressure, please consult your doctor before adding cold exposure. The cold triggers a vasoconstrictive response. Blood vessels narrow, which in a healthy cardiovascular system is a beneficial training stimulus, but which in a compromised one can be a stressor you do not want unsupervised. Second, enter cold water slowly and carefully. The combined effects of cold and postural change can cause brief lightheadedness, and fall prevention is paramount. For the majority of adults over 75 without cardiovascular contraindications, the evidence is genuinely compelling. 2 to 3 minutes of cold water at the end of your shower 3 times a week is one of the most targeted mitochondrial interventions available without a prescription. Habit 2, they have something they are doing, not just something they enjoy, something they feel they are contributing to, building toward, or responsible for. I want to address this one carefully because it is the habit that most sounds like generic life advice and least sounds like biology. But the biology behind it is direct, well documented, and in some studies more predictive of longevity outcomes than diet or exercise. The concept that the research uses is ikigai, a Japanese term roughly translating to reason for being. The term has become popular in longevity circles, but the underlying construct, having a clear sense of purpose and structure in daily life, has been studied rigorously independent of the cultural framing. A study published in JAMA Psychiatry in 2019, following 6,985 adults aged 65 to 92 over 4 years, found that those with the highest sense of purpose had a 15 to 30% lower risk of cognitive decline, a significantly lower incidence of mild cognitive impairment, and meaningfully lower rates of depression and anxiety-related physical health events. These effects held after controlling for physical activity, social engagement, and baseline health status. The mechanism runs through the hypothalamic pituitary adrenal axis, the stress response system. When a person has a clear reason to engage with the day, something to do, something to contribute to, something that gives the day a shape, the stress response system maintains what researchers call allostatic balance, the adaptive, proportionate management of daily stress that keeps cortisol and inflammatory markers in healthy ranges. When that structure disappears, as it often does after retirement, after a spouse passes, after children no longer need care, the stress response system can either become hyperactivated in the absence of structure to manage, or it can flatten, a low arousal state with blunted cortisol response, reduced dopamine activity, and what clinically presents as depression, but is better understood as a system that has lost its anchor. Both states, hyperactivation and flattening, accelerate the inflammaging process I described at the beginning. Chronic stress without a purposeful outlet and purposelessness without activation both drive the same inflammatory cascade. What the research supports is not a particular kind of purpose. It is the presence of one that is personally meaningful and that structures daily life in some way. For some people, this is a creative practice. For others, it is volunteering, mentorship, caregiving for grandchildren, community leadership, part-time work, or a craft pursued seriously. A 2020 study in The Gerontologist found that adults over 70 who reported feeling needed, specifically the sense that others depended on them in some way, had significantly lower interleukin-6 levels, lower cortisol variability, and better preserved hippocampal volume compared to adults who reported no such sense. Feeling needed produced measurable changes in brain structure and inflammatory biology. The practical question is not philosophical. It is structural. Does your day have shape because of something you are doing or contributing to? Not because of a schedule imposed on you, but because you have chosen a reason to engage with the next week, month, and year? If the honest answer is no, if retirement or loss or circumstance has left the day without that shape, the habit to build is not finding grand meaning. It is starting smaller. One commitment per week to something outside your immediate domestic life. One recurring role, however modest, that requires your presence and contribution. The biology responds to the behavior, not to the feeling about the behavior. You do not have to feel purposeful before you act purposefully. The feeling follows the structure, and the number one habit, the one that ties all the others together, and the one I find most underestimated by virtually every conversation about aging well. They pay attention to early signals. They have developed the habit of noticing small changes in their own function, and they respond to those changes rather than waiting for them to become large. This sounds simple. It is not. There is a deeply ingrained response pattern in this age group, one that is understandable and even, in some historical medical contexts, encouraged, where changes in function are attributed to age and therefore accepted as inevitable and not worth investigating. My balance is not what it was, that is getting older. My memory is a little slower, that is getting older. I am more tired in the afternoon than I used to be, that is getting older. Sometimes those things are getting older, but sometimes they are not. And the adults who age most successfully have learned, through whatever combination of information, experience, and temperament brought them there, that their body is continuously giving them information, and that information is worth responding to early. Here's the clinical context for why this matters specifically after 75. Most of the conditions that create dramatic health events in this age group, cardiovascular disease progression, kidney function decline, diabetes deterioration, early cognitive change, follow a pattern where the most responsive window for intervention is early, when the signal is subtle, when the biomarker is moving in the wrong direction but has not yet crossed into the range that triggers a diagnosis. That early window is where behavior and medical intervention produce the largest return. A 2021 study in the Journal of the American Geriatric Society found that older adults who proactively reported functional changes to their physicians, small changes in balance, energy, memory, or stamina that they noticed before those changes became clinically measurable, had significantly better health outcomes over the following 5 years compared to adults who presented only when symptoms were severe. The researchers identified this as a behavioral pattern, not just a personality trait. It was associated with specific practices, regular self-assessment of functional capacity, a relationship with a primary care provider that the patient trusted enough to raise concerns without feeling dismissed, and the absence of the cultural script that says minor changes in function are not worth a doctor's time. There are 4 domains where early noticing matters most in this age group. Balance and gait. A change in how you walk. A slight widening of stance. A hesitation at curbs. A new reliance on a handrail you did not used to need is often detectable months before it becomes a fall risk. These changes can reflect changes in inner ear function, peripheral nerve health, medication effects, or early Parkinson's pathology. They are treatable when caught early. Cognitive speed, not just memory. Most people monitor for memory lapses. What is often more diagnostically meaningful is processing speed, how quickly you can retrieve a word, follow a conversation in a noisy room, shift between 2 tasks. A subjective sense that these are slower than they were a year ago is worth mentioning to a doctor, especially if others have not noticed it yet. Grip strength and general stamina. A measurable drop in grip strength or a new sense of fatigue with activities that were previously unremarkable can reflect changes in muscle integrity, thyroid function, cardiac efficiency, or hemoglobin levels. These are testable and often correctable. Sleep and appetite shifts. Meaningful changes in sleep architecture or appetite that persist beyond a few weeks are worth raising. Both are early indicators of depression, thyroid dysfunction, medication effects, and other modifiable conditions that, left unaddressed, accelerate biological aging significantly. The habit to build is not anxiety about your body. It is a regular, calm, monthly self-check. A few minutes at the end of each month, honestly assessing whether your function in these 4 domains feels the same, better, or different than last month. And a physician relationship where you feel comfortable raising the things that feel different. If your current doctor dismisses concerns you raise, if your questions are met with "that is just aging" without investigation, that is not a reason to stop noticing. That is a reason to find a doctor who listens. Let me pull the 5 habits back together because they are more connected than they appear. Eating within a consistent daily window activates autophagy, the cellular cleanup system that removes damaged components before they accumulate into disease. Moving within the first hour of waking anchors the circadian rhythm, optimizes blood glucose response, and amplifies the cortisol awakening response that drives morning cognitive function. Deliberate cold exposure, even 2 to 3 minutes of cold water, 3 times per week, activates mitochondrial biogenesis through PGC1 alpha and drives measurable reductions in inflammatory markers. Maintaining a sense of purpose and daily structure keeps the stress response system calibrated, reduces inflammaging, and preserves hippocampal volume, the brain structure most vulnerable to early aging. And noticing early, paying attention to subtle shifts in function and acting on them, keeps all of the above from being undone by a condition that was treatable in its early stages and became serious because it was attributed to age and left alone, 5 habits, none of them extreme, each of them with a specific mechanism, each of them available to you tomorrow. A note before you go. If you are managing chronic conditions, heart disease, diabetes, kidney disease, joint problems, please work with your doctor when you are implementing changes to your eating window, your exercise routine, or adding cold exposure. These habits are broadly evidence-based and well tolerated, but the right parameters for you depend on your specific health picture. Tonight, I want you to do one thing. Pick the single habit from this list that you are currently doing least consistently and write down what the smallest possible version of it looks like. Not the ideal version, the version you could actually start tomorrow. Tell me in the comments, which of the 5 are you strongest on? And be honest, which one have you been avoiding? I am particularly curious about the cold exposure. Has anyone already tried it? What happened in the first week? If someone in your life is over 75 and this kind of information would be useful to them, a parent, a sibling, a friend, please send it along, not as advice, just as something worth hearing. Next video. There is a reading on a standard blood panel that most adults over 65 have checked every year, and most of them have never had it properly explained. It measures something that, when it trends in the wrong direction, silently increases cardiovascular risk and accelerates brain aging. Your doctor sees the number. Most do not explain what it means or what you can do about it without a prescription. That is what we cover next. Worth staying for.